We have problem 5. The point P is a comma b and is in the xy plane, and let's suppose that that point is right here, right, a comma b. We also know that it's first rotated 90 degrees about the point 1 comma 5. We'll get to that later. So let's call this 1 comma 5. Then the resulting point, let's say it's somewhere here, P prime with C comma D. And then we know that point is then reflected across y is equal to negative x. So first of all, how do we model that? Well, try y is equal to x, right? In the transformation y is equal to x, what happens? Y becomes x, x becomes y. So in this case, if the original point was 1 comma 3, then the transformation y becomes x, so that's 1, x becomes y, so that's 3. So this will be the resulting point. So likewise, we can do it for the same. Y is equal to negative x. How would that go? Well, y becomes negative of x, and x becomes negative of y. So in this case, if I had P prime, or P1, not prime, P1, C comma D, and I wanted to do it across y is equal to negative x, then that becomes, let's call it P2 point, and that would be E comma F. And E comma F, well, E would be the negative of D, right? Or rather, F would be the negative of D. No, F would be the negative of C, because remember, C is the x in this case. So this becomes P2, and this becomes negative C, and D, well, x becomes negative y, so negative D. That should equal to negative 6 comma 3. So that means the final point is equal to negative 6 comma 3. So now that we have this, how do we go backtrack, right? We have to, from here, go back to P1 and then go back to P. So to do that, how would you reflect negative 6 comma 3 across the line y is equal to negative x? Because you got to go back. So that's the same thing. Y becomes negative x, x becomes negative y. So going back to P1, y becomes negative x. So negative of negative 6 is 6. X becomes negative y, so this becomes negative 3. So P1 is negative 3 comma 6. And now we know that it's going 90 degrees, going from here and back to here. So to do that, we can draw lines out, right? Negative 3 comma 6 and 1 comma 5. These are the points. So what is the slope of this line? Well, that's equal to negative 1, 5 minus 6, 1 minus negative 3 becomes 4. And we know that perpendicular slopes k times k1 has to equal to negative 1. So that means the slope of, let's call this point B, the slope of PB, right, has to equal to, negative 1 divided by negative 1 over 4, which is equal to 4. So the slope of it is 4. So in the general form, y is equal to 4x plus b. And now we know it passes through the point 1 comma 5. So 1 comma 5, that becomes 1, this becomes 5, so b becomes 1. So the line connecting PB is equal to 4x plus 1. And now we don't know what this point is, right? But we can tell by the relationship of P1 with B. So P1 is negative 3 comma 6, and we know that 1 comma 5. Well, how do we relate these 2 points together? Well, this so to get from one y to the other y, we subtract 1, so y becomes subtract 1, and x you add 4. You add 4 to it. So you add 4 and then you subtract 1. So add 4, subtract 1. And then in this case, instead of that, it would be the opposite. It would be going so it would be the opposite. So it would be going left by 1, or right by 1, and up by 4. So right by 1 becomes 2, up by 4 becomes 9. So then if we have this, what's the slope? The slope is 4, so that would checks out. So this is the final point of P, which 2 plus 9, or 9 minus 2 rather, is equal to 7, bringing you to answer choice D.